You're welcome to Explore Insights. In this video, I want to talk about on how to identify MAC and IP address using the Cisco Packet Tracer. So basically, we have two objectives. One is to gather the PDU information for local network communication, and the second is to gather the PDU information for remote network communication. Now, let me break things down. First of all, when we talk about the MAC address, MAC simply means the media access control addresses. You can also call it the hardware address or the physical address, or better still, the Ethernet hardware address. These are other names that could replace the name MAC address. For IP address, it is also referred to as the Internet Protocol address. For the MAC address, it works in layer 2 of the OSI model, precisely the data link layer, whereas the IP works at the layer 3 of the OSI model, precisely the network layer. Now, looking towards the left-hand side, you can see the configuration already done. However, if you want to configure this, you just need to create a new file and replicate this. All you need to do is to recall the network devices you need and also the cables. In this scenario, we have one router, two switches, four PCs, two laptops, the access points, and the hub. And for the cable, we have the fiber, the copper straight and crossover cable, and also the wireless connection. Going back to the background, I also want to emphasize on the PDU, which means the protocol data units. It is a basic unit of exchange between entities that communicate using a specified networking protocol. So looking at this background, this activity is optimized for viewing PDUs. The devices are already configured, as you can see on the left-hand side. So we will gather the PDU information in simulation mode and answer a series of questions about the data you collect. Instructions will be following some instructions to guide us for part 1 and part 2. For part 1, recall, we are to gather PDU information for local network communication. So note that you need to review the reflection question in part 3 before proceeding with part 1. This will give you an idea of the type of information you will need to gather PDU information as a packet travels from 172.16.31.5 to 172.16.31.2. So what do we do? In the first instruction 1A, we have to click on 172.16.31.5 and then open the command prompt. So looking at this configuration, we could locate the 172.16.31.5 here, and we are asked to go to the command prompt. So basically, when you open this, you won't see the command prompt. All you need to do is to click on the desktop, which will take you to the command prompt seen here. Now click on the command prompt. Go back to 1B. 1B says you should ping 172.16.31.2. Now, when you get here, you're going to type ping 172.16.31.2. Now you click on the enter key, and here you can see that it was successful. Now let's go back to the next thing. It says switch to the simulation mode and repeat the ping command again. A PDU appears next to 172.16.31.5. Now, what you can see here is actually on the real-time mode. We are asked to go to the simulation mode, which you can see here. Already on the real-time mode, moving over to the simulation mode. So you just click here. Now, when you do that, we're going to repeat the ping again. So it means we are going back to the command prompt to get the ping done. So you don't need to type again to ping. All you need to do is click on your forward arrow and it should bring back what you've typed. So I'm pinging again. And it says, immediately you ping, you're going to see the PDU close to the address 172.16.31.5, which you can see here. Now, let's see what we have for 1D. 1D says, click the PDU and note the following information from OSI model and the outbound PDU layer tabs. So we are clicking here to see for ourselves. Now, this is the OSI model and this is the outbound PDU details. Now you have to locate and find the information which has to do with the destination MAC address, the source MAC address, the source IP address, the destination IP address. So let's see this through. Okay, so at the OSI model, just looking here, you could see at device, we have 172.16.31.5. Also for the source, we can see 172.16.31.5 as stated here. And also we can see the destination as 172.16.31.2 as stated here. Now, we could also see that in layer 3, we could identify the IP header, the source IP address, SRC means source, and then the IP address, which is this. And then DEST means destination IP address, which we've gotten here. Now, this layer 3 tells us about the network layer, and the protocol you can also find in the network layer of OSI model is IP, ICMP, and others. So this is why we can get information right here. And layer 2, which has to do with the data link, tells us about the Ethernet 2 header, which also covers the MAC address of the source and the destination MAC address. And here, which is layer 1, tells us about the physical layer, which has to do with the ports. So in this case, we used the Gigabyte Ethernet 0. So having identified all this information in the OSI model and outbound PDU layers type, we'll move over to 1E. Now 1E says, click capture or forward the right arrow followed by a vertical bar to move the PDU to the next device. Gather the same information from step 1D. Repeat this process until the PDU reaches its destination. Record the PDU information you gathered into a spreadsheet using a format like the table we can see below. And here is the table. So how do we click forward? You get back to your simulation panel, which is the mode, and you click this represents forward, whereas this represents backward. So we are asked to go forward, which is the forward arrow followed by a vertical bar. So I'm going to click here. So when you click here, what happened is the PDU moves from the PC, which is 172.16.31.5, over to the switch. And when it moves over to the switch, we are asked to click on the PDU and to gather the information from the OSI model and the outbound PDU details. So we have clicked here. Now look deeply in what we have this time. You could see that we have the OSI model, the inbound PDU details, the outbound PDU details. Now, let me click to take you through all of this subsection. Now, this tells us that the device here we have is switch 1, and for the source IP address, we have 172.16.31.5, telling us that it's actually coming from this PC. And here is the destination we are planning to go over, which is the 172.16.31.2. In this part, which is the in layers, it is giving us information about the MAC address, which is also all about the data link layer, layer 2 of the OSI model, where we have this as a source MAC address, and this is the destination MAC address. And for the layer 1, it tells us the port in which we're using. In this case, we used the Gigabyte Ethernet 1/1. Going over to the out layers, in this case, it precisely tells us layer 2 and layer 1. Now recall, the switch only works in the layer 2. This is why you cannot find information about layer 3, layer 4, layer 5, layer 6, and layer 7. Now layer 1 to 7 tells us fully about the OSI layers, which ranges from the physical, the data link, the network layer, and so on, down to the application layer. Now in the layer 2, in this case, we have the source MAC address given as this, whereas the destination MAC address given as this. Considering the physical layer, which is the layer 1, the port used in this case is Gigabyte Ethernet 3/1. So correlating it to the spreadsheet format, in answering this question, you could see that in switch 1, the destination MAC address is what we have here, which is the same. And then the source MAC address, represented by CRC source, is what we have here, which is the same. Now, not applicable for the source IP address and also not applicable for the destination IP address. It's because the switch only works in the layer 2. So it means that we got no information about layer 3 because we cannot get the IP address for the source and the destination address, since the switch works only in layer 2 and not layer 3. Now, we are asked to repeat this process until the PDU reaches its destination. So that means that we need to continue pressing the forward till it gets to its destination, and the destination is 172.16.31.2. So it means that I need to press forward till it gets to this point. So let's do that together. Now my PDU has moved from switch 1 to the hub. Now let's click the PDU and see what we've got. Now this information tells us, or has given us, the PD information at device. Which device? The hub. Now it tells us that the source IP address is 172.16.31.5. Still the same information, telling us that it's actually coming from this PC and going to this PC. So this is the destination, whereas this is the source. Now take a look here. This is quite different. Why? You could only see the information in both the in layer and the out layer only in layer 1, which is the physical layer of the OSI model. Why? Because the hub only operates on the physical layer. And in this case, it tells us the port, which is the fast internet 0 for the in layers. Whereas for the out layers, we have the fast internet 1 and also have the fast internet 2. And the information we have here is the fast internet 0 receives the frame. But remember, we've not gotten to the final destination. All we need to do is to still press forward. So I'm coming here to click forward. Yeah, so did you observe something? Take a deep look here. Now, this is our destination, but this wasn't our destination. So this is why you could see a red cross to tell you that we are not supposed to report to this. This is actually the correct destination. Okay, so let's move on with what we have here. Now, as I've clicked on the final destination, that's PC, the PDU close to the PC. Now, this is what we have, telling us about the PD information at the device 712.16.31.2, which is the destination IP address. Now, we have the in layers and the out layers consisting of the 7 OSI model layers. Now, in this case, we are having an information of the layer 1, layer 2, and layer 3. Here, the layer 1 tells us about the physical connectivity. In this case, we have the port as fast internet 0. In layer 2, we talks about more about the MAC address, This is the source MAC address, whereas this is the destination MAC address. And it gives us an information about the Ethernet 2 header. Moving over to layer 3, which is the network layer of the OSI model. It specifically tells us about the IP header, where we have the source IP address as this and the destination IP address as this. Also, we have the ICMP message type 8. Remember, ICMP means Internet Control Message Protocol, and is a protocol that devices within a network use to communicate problems with data transmission. So this is also one of the protocols we can find in layer 3, which is the network layer. Moving over to the out layers, this is also what we've gotten here. Here, in this case, the source IP is 172.16.31.2. The destination is 172.16.31.5. And the ICMP message type we've gotten here is 0. Moving over to the layer 2, which is the data link layer, we have the Ethernet 2 header 000C. Here is the source MAC address, and here is the destination MAC address. In layer 1, which is the physical layer of the OSI layer, we have the port as fast internet 0. So the question is, have we completed everything? Yes, we have, since we have gotten to the final destination. So everything I said will be recorded below. Now take note, why do we have not available, not available, not available, not available when it comes to the device hub? This is because the hub doesn't operate in layer 2, which talks about the MAC addresses for both the host and the destination. Also, the hub doesn't operate on layer 3 that has to do with the network layer of the OSI model. So this is why we cannot have any information other than layer 1, which talks about the physical layer. Now, when we got to the destination where we are actually pinging to, which is the 172.16.31.2, we have the destination MAC address as this. And also we had the source MAC address as this. Also, for the source IP version 4 address, we had it as this, and the destination IP address as this. Just a recap of what I've shown you here. So without much delay, let's go to step 2. In step 2, we are asked to gather additional PD information from other pings. So what are we going to do? In this case, we need to repeat the process in step 1 and gather the information for the following test. So we need to ping 172.16.31.2 from 172.16.31.3. This is simple English. All we need to do is, first of all, we have to look for the device that has the IP address 172.16.31.3. And thus we can locate it here. So I'm coming here to click on desktop and click on command prompt. What am I asked to do? We are asked to ping 172.16.31.2. So that was successful. So since we had to ping 172.16.31.2, we have to follow the previous step we've taken, which is in step 1. So we move from the read time to simulation again. So while on simulation mode, I'm trying to ping it back. So we could have the PDU, which you can see right here. Just take the step we've done before. Now, while we have the PDU, I'm going to click on forward, as seen here, which will go directly to the hub. And when we click that, we will check the information we've gotten. So just like I said, we can only get information for layer 1 because this is where the hub operates. In this case, the port is a fast Ethernet 2, while in the layer 1, we have the port as fast Ethernet 0 and also fast Ethernet 1. Let's click until it gets to the final destination, which is this. So I'll click, and then we have it here. Recall, this wasn't the final destination. This is why you have the red cross. This shows the final destination with no S red cross. So clicking on the PDU, let's see what we've gotten. Now in this case, you can see the information from layer 1, which is the physical layer, down to the network layer. It also displays the IP address. It also displays the IP addresses for the whole. It also displays the IP addresses for the source and the destination, and also the ICMP message type being 8. And the layer 2 information, which shows the source MAC address and the destination MAC address. The same follows suit in the out layers, where the description can be seen clearly. So we are repeating the same ping. For this section, we are asked to ping 172.16.31.4 from 172.16.31.5. So let's go ahead to do that. Where can I get .5? Now we have our .5 here, and we are asked to ping 172.16.31.4. Where is .4? We can locate .4 here. So it moves from here to here, down to here. So let's go back to read time and then click here. This time we are having .4. So we have .4, we allow it to ping, and that was successful. So why don't we that? We go back to the simulation mode and come back to ping again, just to get the PDU by the side. We'll ping again, and here you'll see the PDU will appear. Now click on forward. As you see me doing, I try to get the information from the PDU, which you can see here. So you can literally see the information for the layer 2 and layer 1 in the in layers, and for the out layer, you can see the information. All this information you've gotten should be written out in a spreadsheet table, which we'll look after this illustration. Now, we've not gotten to the final destination. There is need to still click on forward to get to the final destination. And that's what we're going to do now. So we'll click on forward, and that takes us to the final destination, which is .4. Click also the PDU to get the information there. In layers, we have layer 1 to layer 3. Also here we have layer 1 to layer 3. Look deeply to see the information for the source and for the destination of both the MAC addresses and the IP addresses in the in layers and the out layers. Also take a look at the physical layer, what port was used. At both sides, we have Gigabyte Ethernet 0. So having done that, we could see that we have accomplished this task, and take a look at the table. You should have a report like this, just like what I have just illustrated. So let's go to part 2. Recall, part 1 was just about gathering PDU information for local network communication. We are moving over to the next part, which is to gather PDU information for remote network communication, because that has to do with wireless. Now we have here that in order to communicate with remote networks, a gateway device is necessary. Study the process that takes place to communicate with devices on the remote network. Pay close attention to the MAC addresses used. So we are starting with step 1, which is to gather the PD information as a packet travels from 172.16.31.5 to 10.10.10.2. So it means we're moving from here over to here. Remember to set this as read-time mode. You can also use Shift R. Now, what we need to do is get back to 172.16.31.5 and then you ping 10.10.10.2. So let's do that right away. So I'm going to ping 10.10.10.2. So that shows successful. Then I'll switch over to the simulation mode to repeat the ping again. So just part of my shortcut, I'm just going to use my forward arrow and reping again. So this is just to get the PDU out. Now looking over here, we are asked to click the PDU and note the following information from the outbound PDU layer tab. So take note of that. So I'm clicking the PDU, the outbound PDU details. This is what we'll get. Okay, so this is the information you need to see. So in this case, the destination MAC address can be seen here, whereas the source MAC address can be seen here. The destination IP address is this, and the source IP address is this. At what device? We have this 172.16.31.5. So we have a question here. What device has the destination MAC address that is shown? Now, the destination MAC address we have here has to do with the laptop 10.10.10.2, which is the device here. Now, click Capture Forward and move the PD to the next device. So we are going to move just like we did in part 1. We are going to do the same for part 2. So let's move. So if we click here, we'll click on forward. It takes us to the switch. And while it takes us to the switch, we need to click the PDU to see for ourselves the information there and relate it if it corresponds to the table here. So for the switch 1, we have this for the destination MAC address, and for the source MAC address, we have this. Now, we don't have any information for the source IP address and the destination IP address because they can only be found in layer 3, which is the network layer. And we are dealing with switch, and switch only operates in layer 2, which is the data link layer. So we'll press again forward to move that switch to the next device. And in the next device, we have the router. Click the PDU to get more information on the router. Now take note, the router operates on the third layer, which is layer 3. And this is why we can see the source IP address and the destination IP address here. And also we could see the information about layer 2 and layer 1 all written over here. Now, correlated to what you have down here, does it go in line? Yes. So you could be seeing over here that in this case, we have the destination MAC address, the source MAC address, which is the same as what we can see here. And this also tells us the source IP address and the destination IP address here. Now we'll move over to switch 0. How do we achieve that? By simply pressing forward. That will take us to the next device, which is switch 0. Click again to get the PDU information. So in this case, we have this. Like we said for switch 1, we can only see layer 1 and layer 2 because of the switch. And the same thing, we correlate with the information here. And these are what we've gotten here. So no information for the source IP address and the destination IP address. Click also forward for the PDU to move from the switch 0 to the access point. Click the PDU to get more information at that device. Now the access point could only give us information about layer 1, which is port 0, because it only operates on layer 1. And since it occurs only in layer 1, it means we are going to get all of the MAC addresses and the IP addresses for both the source and destination as not available or not applicable. Now, finally, we press the last forward to get the PDU to the last device, which is the destination. Now, you can see X here because this is not our destination. Meanwhile, here is the final destination with the IP address 10.10.10.2, which we have pinged initially. Click the PDU to get the information. Now, when you click the PDU to get the information, this is what you can find. Remember, the laptop, which is the receiver, also operates in the layer 1, layer 2, layer 3. And also because it is using the protocol ICMP, which is the Internet Control Message Protocol. This protocol works in the network layer. So to this, let's confirm the information for 10.10.2 based on the MAC and the IP address of the source and destinations. So to this, we can really tell that the destination MAC address is this. So in this case, we can get the information from this and this. And for us to also know the source IP address and the destination address, we could see that here. Then to get details about the MAC address, we can find it here. Where this tells us about the MAC, and this one tells MAC source address, and this tells us the destination MAC address. So let's go ahead to answer some series of questions which has to do with the reflection question. Now, were there different type of wire used to connect devices? Yes. Over here, we could see the copper straight through and the copper crossover cable, and here we can see the fiber and also the wireless connection. The next question we have is, did the wire change the handling of the PDU in any way? No. The cable work in layer 1, which is the OSI physical layer. Now, the third question we have is, does the hub lose any information given to it? No, it doesn't. Now, what does the hub do with the MAC addresses and the IP address? Nothing, because the hub works only on layer 1. And number 5, does the wireless access point do anything with the information given to it? Yes, it repackaged it as wireless 802.11. Now, number 6, was there any MAC or IP address lost during the wireless transfer? No. Now we'll move over to question 7, which is, what was the highest OSI layer and the hub and access points used? That was layer 1. And for question 8, did the hub or the access point ever replicate a PDU? That was rejected with a red X. Yes. which we can see at some point I showed you guys. Now let's go to question 9. It says, when examining the PDU details tab, which MAC address appeared first, the source or the destination? It is the destination MAC address. Now moving over to question 10, it says, why would the MAC addresses appear in this order? Okay, a switch can begin forwarding a frame to a known MAC address more quickly if the destination is listed first. Now in question 11, was there a pattern to the MAC addressing in the simulation? No, there wasn't. Now, did the switch ever replicate a PDU that was rejected with a red X? No, because the switch sends frame to the destination. Now, question 13 says, each time that the PDU was sent between the 10 network and the 712 network, was there a point where the MAC address suddenly changed? Where did that occur? It occurred at the router because the MAC address is only relevant in the local area network. Talking about here at this point. Now let's go to question 14. Which devices uses MAC addressing starting with OODO? That's the router. The router here. So for question 15, to what devices did the other MAC address belong? It belongs to the sender and receiver. Now, did the sending and receiving IP version 4 addressing switch in any of the PDUs? No, it didn't. 17 says, if you follow the reply to a ping, sometimes called a pong, do the sending and receiving IP addresses switch? Yes, because PC change their route for their source and destination IP addresses. So it does. Question 18. What is the pattern to the IP version 4 addressing in this simulation? Take note, each port of a router requires a set of non-overlapping addressing. 19 says, why do different IP networks need to be assigned to different ports of a router? Take note, the function of a router is to interconnect different IP addresses. And 20, which is the last reflection question here, says, if the simulation was configured with IP version 6 instead of IP version 4, what would be the difference? Now, just remember that IP version 6 is an upgrade of IP version 4 with more functionality. So IP version 4 addresses will be replaced with IP version 6 addresses, but everything else will be the same because they both only operate in layer 3, which is the network layer of the OSI model. Thank you for watching. Thank you for staying up to this time. I hope you enjoyed this video. Do want to watch my subsequent video on Cisco Packet Tracer lab exercise. Don't forget to hit the like button and to subscribe to this channel. You're most welcome to Explore Insights. Do have a nice time. Bye.